Might say, oh yeah, we had that Mr. Armerding guy as a teacher. Oh wait, it can still hear me. Darn it. I say, no, don't say his name. The way he taught you math is unacceptable. Guys, go on, turn on, grab your Chromebooks out and turn on Desmos. Desmos.com. Did we do that last week? Do we know about it?
Yes.
Okay, good. Desmos.com. In the upper left corner, after you get into graphing calculator, I want you to type this equation using A, lowercase x, by the way. If you use uppercase X, it will assume it's not a variable. H and K. Type in that equation. And it's going to ask you, do you want to make sliders out of A, H, and K? The correct answer, of course, is absolutely. And then go ahead and drag the sliders back and forth. Isn't that cool? What are you missing in your equation?
Oh, I didn't get that.
Caret above the 6. And then put a 3 there. C-A-R-A-T. C-A-R-E-T, I can't remember.
What?
Spelling carrot.
C-A-R-R-O-T.
No, that's the vegetable. This is the weight of precious gems. I think this is the symbol, but I'm not 100% sure.
Doesn't carrot start with K?
No, I don't think so.
Looks wrong.
No, I don't have that wrong. And this is the vegetable.
Well, at least I got one of them.
Yeah.
I'm just not sure if those are different or if they're both the same. We would have to look, but it doesn't really matter.
Oh, carrot is gold.
What?
Carrot is gold.
Precious metals and stones in general, they're like 14 karat gold.
Yeah.
Yeah.
Yeah, I think the E one is correct, because I think the one with AT is another form of.
Yeah. I think going with the A, the top one it's the weight of gemstones. Like a 1 carat diamond. Any questions? Let's talk about yeah, I'm going to make a list. Things we've already done. Y equals x squared. Y equals a parentheses x minus h squared plus k. Y equals x cubed. Y equals a parentheses x minus h cubed plus k. Let's talk about the function y equals absolute value of x. I want you to do a full investigation of that function right there. Now, here's how you find it in your calculator. If you go to the math menu and you arrow over to the number menu, it's option number 1, ABS. Okay. If you're in Desmos, you can use the key on your keyboard that is right above the enter key. There's an absolute value function in there as well, but the key that's right above enter has a backslash and a bar, and you can use that bar. That's just on the keyboard there. So full investigation. Remember what investigate means in our context. I expect domain and range. I expect intercepts. Guys, when you make your table, I want you to be thinking about what might your table look like for a quick graph. Remember that the quick graph for x squared, the quick graph table looked like this. -2, -1, 0, 1, 2, and we said 0, 1, 1, 4, 4. We made it super easy to do a quick graph. The quick graph for y equals x cubed. -2, -1, 0, 1, 2, and of course, that cubed is 0. This is 1 and -1, and this is 8 and -8. So quick graph for a cubic is super easy as well. You just think about the fact that they're the same, but one's going up, one's going down. So I want you thinking about what numbers would be really useful to put into this table if you wanted to do a quick graph of absolute value of x. Yes?
Are we just doing this on paper? Is there an assignment posted?
On paper. This is just in your notebook. Let's see, of course, our investigation is going to include a graph, asymptotes, if there are any, and a description. I think that's everything. Yeah, that should be everything. Cohen, he totally messed me up. Totally messed me up. He sat in Terrell's seat, so I marked Terrell present. But then I knew you were here, so I marked you present. And then I was looking at my thing going, wait, I've got 6 ticks on here and I only see 5 people. What's going on? And then I had to go back and look at my seating chart. Hey, it's my job to make fun of Cohen. Stop it. All right. Guys, let's talk about our investigation. Number 1, Cohen. Pick one. Tell me about it.
The graph.
Good. What does it look like? You know what? Why don't you first tell me which points you put on the table for doing a quick graph of absolute x?
I did -4 to 4.
Oh, that's way too much. That's not quick. That's long. Make it smaller. -2, -1, 0, 1, 2. That's a serious observation, really. There's nothing wrong with going from -4 to 4, but why would you plot 9 points when you could plot 5 points and still get the correct graph? Does that make sense? It's sort of like drawing a line. How many points do you need to plot to draw a line? 2, but 3 is a good idea because it'll catch you if you make a mistake. Plotting 17 points in a row before you draw your line is just like a big giant waste of time. Get 3 points in there, put a ruler on them, boom, line. So we'll go with 5. Cohen, go.
2, 1, 0, 1, 2.
There's the quick graph for absolute value. Start at the vertex, go up 2 in each direction. Why don't I just go up 1 in each direction? Well, if I had a graph that looked like this, could that be a parabola? Yeah. I like to put 2 because then it's really, really obvious that it's not a parabola because I can see that linear pattern going off in both directions. Awesome. Thank you, Cohen. Next, Brooke, pick one.
I actually kind of had a question, so I'll pick the asymptote.
Good, go.
Is y equals 0 an asymptote?
Is y equals 0 a line that the function approaches but does not cross? That's the definition of an asymptote, right? Here is the line y equals 0. Does this function approach y equals 0 and then just keep getting closer and closer and closer and closer, but never actually get to it? And you shook your head no, and that's the correct answer. It's not an asymptote unless it does that. So do we have any asymptotes? No, we do not. So the correct answer for asymptotes is none. Cool. Tyler, pick one.
Domain,
Go.
all real values of x.
I hate all real values of x. Can you give me an inequality? Just to like make it more challenging. What's the lowest value of x?
What's the lowest value?
Yeah,
It doesn't negative infinity.
negative infinity, yeah. And that's got to be less than our values of x, right? And that has to be less than what? Boom.
But isn't it just easy to write all real values?
Well, there's an argument both ways. I I don't know. It could maybe be considered easier, although I think that's easier. I mean, 1, 2, 3, 4, 5, 6 characters, all real values of X has way more characters than that.
Would it be marked wrong on like a test if you?
Do we care, or do we care about just being better?
Both.
I would not mark it wrong on a test. However, now that you've asked me, I will write all of my tests to specifically say, write an inequality to represent each of the domain and the range. And we'll call that the Tyler question. And she'll be like, oh, I hate Mr. Armring so much.
You just made everyone's life harder.
Hey, Tyler, can you do range as well?
Yeah. So I put y is greater than or equal to 0, but is that okay?
That's an inequality. That is perfectly acceptable. Guys, the reason that I emphasize minimum lesser equal to X lesser equal to maximum is because the students who are not in honors typically really struggle with which direction does my arrow go. And if you really want to always get your arrow pointed in the correct direction, you put the smallest number and the biggest number and you put things in between, and the smallest number is always less than the biggest number, so your arrows always go to the left and you never get it wrong. Now, that is actually a mathematically simpler answer which everybody will write once you get up to sort of more advanced math. Nobody would write 0 less or equal to y less than infinity because it's more complicated to write. But they would just write y greater than or equal to 0. Now, here's the other advantage of this min-max thing. There's a thing called set notation, which you will eventually see if you go on in math. And you could say that this, for example, could be written as, oops, nope, not. This, for example, could be written as parentheses negative infinity, comma infinity, which means a set of all numbers between negative and positive infinity. This would be written as 0, comma infinity, which means a set of all numbers between 0 and infinity, and the square bracket means including 0. And then if you just had like something that went from 2 to 3, you would write 2, comma 3, which means the set of all numbers between 2 and 3, including 2 and 3, because there's a square bracket on each end. And so that's the main reason why it's useful to understand this notation, because you'll see that set notation on a regular basis with more advanced mathematics. It's just easier, and you don't have to write inequality symbols. You just write the set of, and it's just either parentheses or brackets. So, cool. Thank you, Tyler. We have 2 more people. Terrell. Henry. Pick one.
I said that the x and y intercepts were both the origin.
Beauty. Ryan, I'm not even going to have to draw your popsicle stick. And you get description. Go.
So I said it increases at a 45-degree angle.
Oh, you're gonna make me get out a protractor and like look at it with a protractor, because maybe it's 44.8. I don't know.
No, not mathematically, it's not.
Simpler. Be simple. Be as simple as possible in description. What's it doing over here, Ryan? Increases? But I read from left to right in the English-speaking world. What's it doing?
Yeah, it decreases to 0 and then increases.
Decreases to 0, 0, then increases. You know, another way to say that would be decrease linear, or a linear decrease on the left, and then a linear increase on the right. And you don't have to say to 0, 0, because that's gonna, I mean, there's nothing wrong with that in this case, but because it's not concave in either direction, saying linear decrease, linear increase is a perfectly fine description. Yeah, no. And what you said would have been okay. The only problem is that if you start to say what angle it's going up at, for one thing, what if I made one that was steeper, which we're going to be doing in a few minutes? Now you have to calculate the angle, and maybe the angle for that steeper one is a decimal, and then you have to approximate it, and I would say stay away from saying it goes up at this particular angle, just because you're making it more complicated than it needs to be. Okay, and you had a question, or did I answer it?
So the decreases to and then increases linear, theoretically, couldn't you say that if it wasn't on 0, 0?
Yes, exactly.
So,
Exactly. So, and this is where I'm trying to be as simple as possible. On the left, I've got a linear decrease. On the right, I have linear increase. Well, where does it change? Well, I'm going to look at all of this as a whole. And if I had already said to somebody, there's intercepts at 0, 0, the domain and range, it's above, they can probably figure out that it has to be coming down until it hits that and going up till it hits that. The main purpose of the description is what happens in between those points. We've got that domain and range. We've got those asymptotes. We've got those intercepts. But what does the curve look like over here versus over there? Think about the cubic. When we did the investigation of a cubic, we said increasing concave down, increasing concave up. To distinguish between a function that goes those are perfectly legitimate functions. They have the same points. But this is not concave down. This is a series of linear functions that are pieced together. This is concave down. It has a constant curve. So the only thing we're doing the description for is as simply as possible, give somebody a visualization of, oh yeah, it looks like that. Or oh yeah, it looks like that. Or oh yeah, it's straight. That's all. That's all. And I would also say that the description is probably the least important part of an investigation. Everything else, I mean, if you got a picture of the graph, well, we already know what it looks like. Look, there's a picture. Look at the darn picture. Don't ask me to describe it for you. All right. Questions?
Does concave have to be a curve?
Yes, because it makes it a cave. That's how I remember that one. Concave is the cave side of a curve. If it's straight, well, there's no cave there. It's not going to keep the rain off your head. Cool. All right. So here's the next question for you. Can you make that go up or down? Go. Grab your calculator or your Desmos, play around with some numbers, make that graph go up or down. Not anything else, just up or down. Tyler?
For up and down, I just did y equals the absolute value of x. plus or minus any number, and I just wrote K, which you can just say plus.
Look at that. Add some number to the end. Every number on that table, if you add 3 to that, then every y value will be 3 higher, and boom, you've gone up by 3. Is that easy? Okay, left or right, not to minimize Tyler's contribution. I didn't mean to minimize what you said. It's that easy making it go up or down once you know what the pattern is. How about left or right? Go. Cody?
Y equals x minus 3 in absolute value.
Which direction does that make it go?
To the right.
How would you make it go to the left?
Change either, yeah, just change the negative or the subtraction into add.
Cool. Yeah, absolutely. Can you generalize this first column? With an H?
Replace 3 with K.
With K? I hate using it.
No, H.
Tyler already laid claim to the K. So, can be plus or minus.
Plus.
Okay. So, you said absolute x minus 3 goes to the right. And so if h equals -3, I'm going to the right. You're okay with that? Are you? Or do you want to change it? Because normally, do we want -3 to mean go to the right in the positive direction? See where I'm going with that? It's okay to be okay with that, but we're not gonna, no, shh, stop it. Stop it.
You should have been at homework today. I got bullied. Stupid Tyrell.
Guys, does it make sense that we really want to say if I choose a transformation number, the positive is to the right or up and negative is to the left or down. So we're going to really try hard to be super consistent on that, just so that we're not switching back and forth in which direction is positive on a number line or on a graph. All right, cool. Vertical stretch. How do I stretch this? How do I compress it? Brooke, what do you think?
But whatever is possible, it'd be A when you put A in front of the X, right in front of the X. So,
You guys okay with that?
Yeah.
What if A is less than 0? Wouldn't it not change?
Wouldn't it have to be on the outside?
well, I tried on Desmos note.
You tried that on Desmos?
Mhm.
And if you made A negative?
8X, and the absolute value of A here is.
Okay. Okay. Tyler?
It doesn't work with negative numbers because the absolute value of a negative number is actually a positive.
Yeah, there's the difference. This will absolutely work just fine as long as your A is positive. So you could make the argument, well, if I want to flip it over, I'll just put a minus sign right out front. But you could accomplish the same thing by putting the A outside, and then you don't have to do two separate things. You could just have a positive or negative value of A, and you don't have to separate them and put the value inside and the negative sign outside. So yeah, this is just a little bit easier, but they're both gonna do the stretch compress. Yeah, absolutely. So let's erase that one and hang on to that one. Guys, let's put it all together. Here's what I want you to type into your Desmos if you have not already. Y equals A, absolute X minus H, close absolute, plus K. Play with the sliders. Watch it go up and down, left and right. Watch it stretch and compress. Watch it flip over. Isn't that cool? Desmos is pretty slick. Hey, as you're moving it around, answer me this. Where's the point H comma K on your graph as you move it around? Yeah?
It's at the vertex, or I guess where it comes together.
Yes, the vertex. You were right. No, that's vertex is one of these words that we get used to. The vertex is the bottom of a parabola. That's not actually strictly true. The bottom of a parabola is the vertex, but that's not what vertex means. Vertex means the bottom of any function that has a bottom. Where it comes to a point and then goes back up again, it's a vertex. Which sort of brings us to the quadratic. H comma K is the vertex, is it not? What about the cubic? What does H comma K represent on the cubic? Why don't you type that one back into your Desmos, the cubic one, and drag H and K around and see what you notice as you drag it around. What does that point H comma K, what do you see there? And you might want to think back to the description of cubic. When we were doing the description of cubic, we wrote the following. Concave, increasing concave down, and increases concave up. This was lower left, this was upper right. Anyone notice anything interesting about that H comma K point? Right?
It's where it changes concave, the curve.
Yeah. Concavity is the word you were looking for. Concavity is the word that described the state of being concave. Yeah, it's where the concavity changes from down to up. And we actually have a special name for that point. It is called an inflection point. An inflection point means change in concavity. Inflection point is a big deal in calculus because when you're concave down, your slope is decreasing. It's getting flatter and flatter and flatter. And when you're concave up, your slope is increasing. Your curve is getting steeper and steeper. So you're changing from a decreasing slope to an increasing slope. And when you start to talk about in calculus, you're talking a lot about rates of change. That's what a lot of calculus is how fast are things changing. Well, if that rate of change is getting less, and then all of a sudden that rate of change is getting more, boom, you've got an inflection point there. Think about driving along in your car and you're slowing down and then you start speeding back up again. That's an inflection point when you go from slowing down to speeding up. I know you hear and you thought math didn't really mean anything. It was just this thing that you learned. Questions? New function. I want you to investigate. Y equals square root of x. Remember when you're making your table? Be thinking about quick graph.
Is there a way to do that in Desmos, or is it just?
Backslash SQRT will change to a square root symbol, I believe, the second you hit the enter at the end of that, or the space.
Yeah.
Or as soon as you hit the T?
Yeah.
Cool. I'm all about keyboard shortcuts. I hate grabbing my mouse to click on things. I love having keyboard shortcuts to do stuff.
Looks like you don't need the slash to do it.
Really?
Yeah,
You just type in SQRT?
I typed that in, and the slash was still there when it changed it.
Yeah.
Oh, interesting. I was not aware of that. That means that you can't type the letters SQRT into Desmos without getting a square root symbol.
Well, I don't know.
That's stupid.
I want to see if that's true.
Yeah, it does it.
Yeah, but what if you just want the letters SQRT?
Then it says
And now I have to
choose
choose
variables.
No, I need them in that order.
There's different
No,
ones.
you choose different ones.
Talk to Desmos. What? Greek.
No, I actually find that interesting because most programs that are using codes will have a symbol that is designed to say, I am about to enter a code. Think HTML. You put the little pointy symbols on either side and it tells the HTML program, I am entering code, so that it won't just type them out. And the fact that this one does not have something to say, I am entering code, interests me. Okay, I'm going to continue to write, you're going to continue to work.
Are you allowed to skip around in your table?
What do you mean by skip around? And what do you mean by allowed?
No.
Can I jump from 1 to 4?
Does it make sense to jump from 1 to 4 for the purposes of your investigation?
Yeah.
Then yes, you may. Yeah.
For all numbers that don't have a definite square root, you want us to simplify it? Like, we had a square root of 17. Well, that's a prime number. Square root of 21.
No, you don't have to. But here's a question. Are they going to be useful for your quick graph?
No.
Because if you said, oh, square root of 17 or 17 comma whatever the square root of 17 is, full point something, it's not an easy point. So don't put that one on your table. Just put the points that you'd be like, oh, well, that's easy, that's easy, that's easy. Boom, I've got enough for the shape of the graph. Okay? All right, let's do it. The only name left in the bin is, well, there's two. Henry, pick one.
The domain range,
Go.
x is greater than or equal to 0, and y is greater than or equal to 0.
Sweet. Also known as 0, infinity and 0, infinity. Got to be a little bit careful because sometimes it has to be really clear from the context that you're talking about domain and range if you're doing set notation, because otherwise it sort of looks like a point. Mr. Hammering, I don't understand how to plot 0, infinity on my graph. Sorry, I can't help you. Ryan, pick one.
Table, I just did 1, 4, 9, 16, 25.
Why?
Because they're all squares.
Yeah, but there's so many of them.
That's 5. That's the same amount that you did on the one, that last one.
Ryan, sticking to it.
I don't want to hear it.
Go.
And then y are just 1, 2, 3, 4, 5.
What about 0?
So my graph, you ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25.
Those are very evenly spaced lines.
Because I'm awesome.
That's a pretty quick graph.
And in the y direction, 1, 2, 3, 4, 5. Do you see why I hate this already?
No.
It's unnecessary. You don't need this to have the shape of the graph. How many do you need for the shape of the graph?
Does 0 count?
I don't know, because I'm going to erase these and I am going to plot Ryan's graph, and then we'll see whether 0 counts. I don't even like the 9 part, but we'll go with it because we have to. We need 3 points because otherwise it could be linear. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. There's the graph of that function. Tyler?
Yeah, it does.
And if I put on 0, 0, do I need 9, 3? I really don't. Because even though it's true, the question is, how far do I need to go to show the shape of the graph? I've got 3 points with a clear downward curve. I'm done. And it's easy. And so why not do that? Does that make sense? Guys, remember the whole point of the quick graph table is quick. The more you put on it, the less quick it is. The more you put on it, the longer it takes you to draw your axes as you go out to all the multitude of points that you've chosen to put onto your table. And if we can look at this and say, hey, you know what, I can do a square root graph with 3 points. Because clearly with my 3 points and a nice big scale, I've got a downward curve. I'm done. Why do you keep frowning at me when I say downward curve?
Well, because when you say downward, I think you.
Concave down.
Yeah.
Okay. Frown, that makes sense. I was like, wait, she keeps doing that. Wow, what am I saying? All right. Restock in the cup. Brooke, pick one.
Intercepts.
Go.
0, 0.
Boom. Henry, pick one.
There isn't an asymptote, right? I don't.
You asking me or telling me?
I'm telling you, there's no asymptote. I think.
If you turn it around, it's not a question. I think there's no asymptote. You guys okay with that? Yeah, there's no value. I mean, we've already said domain keeps going up forever and range keeps going up forever, so there's no limit. And 0, 0 is just where it stops. It doesn't approach a line. It just stops at 0. Cool. Description. Ryan.
Increasing concave down.
Boom. Increasing concave down. All right. Here we go. Ready? Up, down. Left, right. Vertical stretch. Or compress. Hey, Mr. Ames.
Sure.
Somebody want to give me a general equation that includes all three of them? Tyler?
Y equals a times the square root of x minus 8. And then on the outside plus k.
Have I told you guys about the little tail I put on square roots?
Why?
Because it's completely obvious that I intend my square root to end right there. So I was taught at high school, back when I was in high school, and it was just, there's no question that you meant it to go further or you didn't mean it to go so far. Even when you're writing, it becomes very intentional. I want it to stop here, as opposed to, oh, and I made it go too far because I was just being sloppy or not far enough. You really have to think, oh, I want it to stop, and I make the little tail. I find it helpful. H comma K? Anyone want to throw some words up there?
Pick a starting point.
Guys, we'll continue this discussion tomorrow. And I'm going to stop the live stream before I inadvertently put my music on and get banned from YouTube. And then they'd be like, oh, 2 days in a row? You're banned from YouTube for a week.